A very good morning to you all. I've got a question that was asked again in a Facebook group, and I I did my best to attempt it. So it's a quadratic equation, but a bit different than the normal ones. The difference is this one has got complex numbers as the coefficient, and the equation is given below. Equation is 3 minus 2i multiplied by x squared plus 1 plus I multiplied by x plus 2 minus I equaling to 0, and they're telling us to find the value of x. So yes, it's a bit different than the normal ones, but the good news is it is solved pretty much the same way as the normal quadratic equations, and we are going to use the quadratic formula to solve the equation, or the bulldozer. Some people prefer to call this the bulldozer method. I prefer to call it the quadratic formula. And when we extract out the coefficients a, b, c from this equation, we have that our a is equal to 3 minus 2i, and our b is 1 plus I, which is here, and then c is 2 minus I, which is here. So upon substituting these coefficients into our quadratic formula, we have that x is equal to negative 1 plus I plus minus root of 1 plus I squared minus 4 into 3 minus 2i multiplied by c, which is 2 minus I, and then everything divided by 2a. Again, our a is 3 minus 2i. When we simplify the root, whatever that is in the root, we come up with this. We come up with 1 plus 2i plus I squared minus 24 plus 28i minus 8i squared. But we know that I squared for complex numbers, I squared is equal to negative 1. So if I substitute whatever there is I squared here and here with negative 1, this is what I get. And if I further simplify, I have that this negative 16 is the same thing as 9 minus 25 plus negative 16 plus 30i is equal to negative 25 plus 9 plus 30i. Again, if we use the fact that negative 1 is equal to I squared, I can substitute here where there is negative 1. I can put the I squared plus 30i and then plus 9 over here. So I have that negative 16 plus 30i is equal to 25i squared plus 30i plus 9. Now this is a quadratic expression that can be factored, and the factors are 5i plus 3 and 5i plus 3, or just 5i plus 3 squared. So if I substitute whatever that is in the root, under the root is 16, negative 16 plus 30i. So I'm going to substitute this by 5i plus 3 squared, and this square is going to cancel with the square root, and I'm going to have negative 1 minus I plus minus 5i plus 3, or everything divided by 6 minus 4i. And to get the solutions, x1 is going to be, I'm going to take the first case as positive here, or add, and I'm going to have x1 as negative 1 minus I plus 5i plus 3, everything divided by 6 minus 4i. And when I simplify this, I come up with 1 plus 2i divided by 3 minus 2i. Now I want to get rid of the complex numbers in the denominator so that it's easy for me to simplify. So what I do, I multiply the denominator and the numerator by the conjugate of the denominator. Now to get the conjugate of the denominator, we just have to change the sign that is before the complex part. So here we have negative 2i, its conjugate is going to be plus 2i. So the conjugate of 3 minus 2i is 3 plus 2i. So I multiply the denominator and numerator by 3 plus 2i, 3 plus 2i, both on top and at the bottom. So we find that at the bottom, or in the denominator, we have a difference of 2 squares. That is 9 minus 4i squared. And then the numerator, I've got 3 plus 2i plus 6i plus 4i squared. Again, we have to remember that I squared is the same thing as negative 1. So if I substitute negative 1 for I squared, I get in the numerator 3 plus 8i minus 4. And then in the denominator, I'm going to get 9 plus 4. Okay, and my x1 is going to be negative 1 plus 8i divided by 13. And my x2, here I added, here I'm going to subtract. So my x2 is going to be negative 1 minus I minus 5i minus 3. Everything divided by 6 minus 4i. So upon simplification, I get negative 2 minus 3i divided by 3 minus 2i. Again, I have to get rid of the complex, of the complex parts in the denominator. And the way I do that, I'm going to multiply the denominator and the numerator by the conjugate of the denominator. So again, I get a difference of 2 squares in the denominator, and in the numerator I get negative 6 minus 4i minus 9i minus 6i squared. Again, I squared is the same thing as negative 1, so I substitute negative 1 for wherever there is I squared. So I get in the numerator negative 6 minus 13i plus 6, so the positive 6 and negative 6 cancel, and then the denominator I get 9 plus 4, giving me negative 13i divided by 13, which is negative I as my x2. So those are the two solutions for x in this equation. Now you see that it's quite, the way we solve it is quite similar, just that you have to go a little into more steps to simplify the answer, so it makes a lot of sense. So yeah, that's the solution. And if you guys have any questions, if there is anything that is not clear, feel free to comment in the comment section or shoot me an email. I'll be more than happy to answer either questions regarding this problem or any other problems. I'll be more than happy to answer those questions. Until then, have a good rest of the day. Thank you.